Stage 2, LOX load is closed out. Falcon 9 is on internal power. Vehicles and self-align. Gas closeouts.
AFTS is ready for launch.
Falcon 9 is in startup.
Ground gas closeouts.
Dragon is in startup.
Launch directors go for launch.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Falcon 9 is on its way to delivering the Dragon spacecraft for its 14th commercial resupply services mission. Coming up in about 10 seconds, we have max Q, maximum aerodynamic pressure. That's one of the highest stress states on the vehicle.
Vehicle is supersonic. Vehicle is experiencing maximum dynamic pressure.
Just passed through max Q. This first stage burn will last for about another minute and 10 seconds. As we leave Earth's atmosphere, you'll notice the exhaust plume gradually expanding.
Head back engine chill.
And just heard the call out that the upper stage engine, the Merlin vacuum, has begun chilling in, similar to how we chill in the 9 Merlin engines before the initial liftoff of the Falcon 9. Now coming up in rapid succession, at about T plus 2 minutes and 40 seconds, we'll have MECO, our main engine cutoff, followed by stage separation, followed by ignition of the upper stage engine. Let's watch.
We have MECO.
Stage separation confirmed.
Head back ignition.
And what you just saw there was a successful shutdown of the 9 Merlin engines of our first stage, followed by separation of our first stage from our second stage using 4 pneumatic actuators at the forward end of the stage. And then after that, you saw ignition of our upper stage engine. You may have noticed a piece of metal flying away from the engine. That's a stiffener ring that protects the larger Merlin vacuum nozzle on ascent. That's totally nominal. And on the left side of your screen there, that's actually the Dragon nose cone that it's popped off and is falling back to space. Dragon nose cone falling off, totally nominal. That's exactly what we want to see. We use that nose cone to protect the forward end of Dragon on ascent through the aerodynamic, the atmospheric drag we see. That's a good sign. That means we're outside of the atmosphere, so the forces on the forward end of the vehicle are significantly reduced. About 2 minutes into our second stage burn. If you're just joining us so far, the first stage had an on-time launch, just like we like it, a nominal ascent profile, good separation from our second stage. Now that first stage is performing an experimental landing maneuver. We're just gathering some data on this into the Atlantic Ocean. We do not have a drone ship out there in the Atlantic Ocean, so we are not covering this portion of the phase. Though you will probably hear some callouts in a few minutes on entry burn of the first stage. Since that's not our primary mission and we're not intending to recover that first stage, we will just be focusing on second stage right now. Coming into T plus 6 minutes, this second stage burn will last for about another 3 minutes. Our target, if you want to keep an eye, that speed, we're going to about 27,000 kilometers per hour. That's orbital velocity. Second stage's job is to get Dragon to orbit. First stage's job was primarily to get us out of the Earth's atmosphere. Second stage does its precise orbital maneuvering by using 2 thrust vector actuators. They're contained within that reflective blanket, and they allow us to adjust the engine's position, affecting its pitch and yaw. And then we have some nitrogen thrusters on the forward end that allow us to adjust the vehicle's roll. Power and trajectory continue to look good. Engine performance continues to be nominal, as we like around here.
Stage 1, AFTS has saved.
We are coming up shortly in about a minute here on SECO. That's a second stage engine cutoff. That's the point where the second stage in Dragon will be coasting. Dragon will then do a quick checkout, and then it will be deployed from the second stage about a minute after that point in time.
Stage 2 terminal guidance.
About 15 seconds left into stage 2's burn.
Stage 2, AFTSS saved.
And we have shutdown of the second stage engine.
Yes, Eco.
You saw the speed tick up to about 27,000 kilometers per hour. We're going to coast here for about a minute, and then Dragon will separate.
Good, stage 2 orbit insertion.
And we just also got the confirmation that we are in a good parking orbit of our second stage.
Acquisition of signal Newfoundland.
Coming up on Dragon deployment in about 15 seconds. And that is a view from the forward end of our second stage, looking inside Dragon's trunk as it separates from the second stage. Those are 3 of the science experiments we're taking up to the International Space Station. You can see those 3 different boxes inside. Those are 3 of the experiments we're bringing that will be attached on the outside of the International Space Station once we berth.